Hey everyone, welcome back to the bench. Today on the bench we got a little project kit here to assemble. It's a Phono preamp. If you watched my video about the turntable I got, I said, well, I need a Phono preamp because I don't have one. And I was going to use Rod Elliott's preamp design. I thought it was pretty good. And I built it on a socket board and made a video of it many years ago. And I was going to build this one on a perf board. But somebody contacted me and said, hey John, I'm going to build a preamp. I'm going to buy the board. Why don't I just buy a board for you and send it to you? So that's what he did. So I really appreciate that. Sent me a Rod Elliott board. Looks like there's components included. I thought I was going to have to put a DigiKey or Mauser order together, but I don't know. I think it's all there. I don't know. We'll open it up. I haven't opened it up yet. If you're not familiar with Rod Elliott's site, just go to ElliottSoundProducts.com. I'll put a link down there. He has a lot of projects. Some of them you can order boards for. You'll have to get your own components for the boards, but he does sell boards. If you're into audio stuff, he has various amplifiers and filters and different things you might be interested in. Okay, so before I get into this, I should mention, why do you need a Phono preamp? Well, with better quality turntables, they will use a magnetic cartridge, and you need to bring the voltage up to a level for the amplifier. So it's called a preamplifier. See, the output of a typical magnetic Phono cartridge is just a few millivolts, and the standard for line level is around 1 volt. Now, most integrated amplifiers and receivers will have a built-in Phono preamp stage, so you don't need an external one. But in my case, my do-it-yourself amplifiers do not have preamps. Another reason is the equalization, and that requires a little bit more explanation. To explain equalization, I drew these vertical waveforms. Think of them as grooves on a record. You're looking at the front of the cartridge. So with these magnetic cartridges, they found to have flat frequency response, you'd have to make the amplitude of the lower frequency notes much larger than the higher frequency notes. And that's because, well, the coil and magnet are moving slower relative to one another. At high frequencies, they're moving a lot faster. And when you move the coil across the magnet at a slower rate, it produces a smaller voltage. So you end up with a very poor low frequency response. So what they have to do is make the amplitude of the lower frequency notes larger. The lower the frequency, the larger the amplitude. But that poses a new problem. Well, that takes a lot of room up on the record. Now you want to have the grooves close enough together so you can have enough playing time on the record. Another problem is, well, high frequencies, they don't have very much amplitude at all, and it has to compete with surface noise. Even with a perfectly pressed record, there's still microscopic imperfections, and that's going to compete with the sound or music coming off the record. So their solution was to make the bass notes smaller so they don't use as much space and emphasize the high frequency. And in playback, they reversed that effect using a Phono equalization stage. And what that does is amplify the bass more than the high frequencies. So now that the bass is smaller, you can have a longer playing record. And the emphasis with the high frequency gives it distance from that surface noise. So in a way, it's kind of like a noise reduction effect. So that's why we need a Phono preamp. Well, back in the early days of hi-fi, there was another problem. They came up with a bunch of different standards for these equalization curves. And in this book from 1954, it's listing the different record companies and what they're calling low frequency turnover and the high frequency roll off. You can see there's several different standards. So to play a record, you'd have to have a Phono preamp and equalizer like this unit here. And for low frequency, you had 4 different settings. High frequencies, you had 4 different settings for 16 different combinations. There's some examples of other ones. Didn't have as many adjustments. Well, just a couple years after that book was printed, I believe it was the RIAA, the Recording Industry Association of America, said, all right, enough of this. We're going to have one standard for equalization. So no more switching every time you're playing a record from a different record label. It was all standardized. In fact, Phono preamp stages moved into the integrated amps or receivers. So all you had to do was plug your turntable into the back of your amp or receiver, and you didn't have to worry about switching equalization anymore. Matter of fact, a couple years after this book was printed, they come up with the, I believe it's called the West Trek stereo standards for phonograph records, which we still use today. And it's how they were able to encode stereo in the grooves of the vinyl. So here's the kit unpacked. Again, I should emphasize that when you order the board from Rod Elliott, that's what you get, just the board. The fellow who sent this to me supplied all these parts. And again, I really appreciate that. He went for the high-end stuff. You know, some Dale resistors, WEMA caps, looks like Panasonic branded electrolytics, LM4562 op amps. He also included this power supply board, which is much larger than the Phono preamp itself. This is a special quiet type power supply. I don't think I'll use that though. I might use it for something else, but if you want to build a quiet dual supply for audio op amp circuits, that's something interesting there as well. I'd have to come up with my own components though. So what I'll do now is assemble this thing. I'll look at the manual. It just contains the bill of materials and your typical assembly instructions. So I'll turn off the camera and get to assembling this thing. Ooh, fancy audiophile. Looks like a little plant with all the silos and buildings and stuff. But yeah, it's been 3 weeks. I soldered this thing together. It's just been sitting on the bench. Just been busy working on the house. Work coming in. People driving me nuts with work. I'm not sure what's going to go on this summer. They're telling me I got a bunch of work to do, so yeah, we'll see. Hopefully I can get some YouTube videos out. I got like a backlog. I just can't get to it right now. But anyhow, what I decided to do with this thing is test it out, make sure it's working and everything. And in a later video, I'll put it in a case. It needs to go into some sort of metal enclosure. Being amplifying a fairly high impedance, low signal level, it'll pick up noise pretty easily. So it's got to go into some sort of metal cabinetry, and I'll do that in a later video. Anyhow, let's move ahead here and get this thing tested. Okay, I have the board wired up. I'm not using connectors. It's going to be in a case, so it's never going to be unplugged or anything, so I just direct soldered the wires. Running them through the mounting holes right now, since I'm not in a case, I want those to act as a strain relief, so as I'm moving this around I don't weaken the connections and break the wires off. For power, I'm just using a 9-volt battery, a little circuit here to make a virtual ground so it can be fed a plus and minus voltage. The LM4562s I'm using will run happily at plus and minus 2.5 volts without any hit to linearity. And of course it'll be more than that This battery's not fresh, so I'm getting around plus minus 4 volts. Just have to make sure you have enough headroom with the signal to drive your line in on the amplifier, so we should be fine there. So this line goes over to my little amplifier here, which is connected to the speakers. So let's power it up, see what happens. Yeah, I can hear hum and hiss. It's not in any case. I bring my hand near it, you can hear the hum. I'll touch the input. Okay, so both channels are working. Don't do this if you're connected to a high power amp or something, because you could damage your speakers or blow something up. Yeah, I'm not worried with this. I know it's not going to hurt anything. It's not a lot of power. So yeah, looks like it's powered up. I'm going to short the inputs and kind of get an idea of the background noise level. Okay, I grounded the input. So let's power this thing up. And yeah, pretty quiet. I've listened to the Phono preamps in receivers, how noisy those things can be. I mean, if I turn the volume up really high, you can hear hiss. Hear a little background hiss. I mean, you're always going to have some, because that's a pretty high gain amplifier. So at normal listening levels, you're not going to hear that. The noise on the vinyl is going to be quite a bit higher than that. So what I want to do now is send this thing to the asylum. Yeah, the Quant Asylum. I want to take a couple measurements here. Then after that, we'll hook up the turntable and give it a quick listen. Alright, hooked up to the Quant Asylum. So I'm going single-ended here on the inputs. I have these terminators on the other connectors here. Driving 10K ohm loads from the output. That's your typical input impedance of your power amp, give or take. And adjusted it here. Here's the distortion at 1 kilohertz. Low, low, low. Don't worry about the power. It's not connected to 8 ohm loads or anything, and it's not a power amp anyway. I just left that measurement up on the screen. I can't do a distortion plus noise. Obviously, it's sitting out in the open, picking up noise. You're getting that large peak, 60 hertz getting in. And if I bring my hand near the amp, yeah, see, it goes crazy. So yeah, I can't do a distortion plus noise until I put it into a cabinet. But yeah, very impressive. Maybe at some point I'll do more distortion tests at different frequencies. But what I really want to see is its frequency response. Okay, so what we're looking at here is the frequency response of the equalization / preamplifier. And well, if you look at Rod Elliott's site, the green line is the response. And if I knew what I was doing, I could set this point at 1 kilohertz to be 0 dB. But, you know, it's all relative. So the bass should go up about 20 dB, which it does. And the high should roll off down to about minus 20, which it's pretty close. And what I really like here is I'm showing both channels, the red and the yellow curve here. They overlap. And that's one reason you want to use good quality capacitors and 1% resistors, because you want those channels to overlap as much as possible. But yeah, we're seeing pretty much the same thing, which is on the screen here. My curve might be steeper. That's because I'm zoomed in vertically a little bit more, but this thing is doing the business. It's doing what it's supposed to do. Oh, and did I mention that I love this Quantasylum audio analyzer? Okay, let's see what's going to happen here. How about some count 5? Got everything hooked up. I had to cut the ends off from this turntable. These are bad. I tried to clean them, bend them. I can't get a good connection, whatever I plug into it. Okay, the tone arm is released. We're in 33 speed. Let's see what happens here. Entering the age of vinyl here on the John Audio Tech Show. I don't hear anything. Get this up. This thing's deader than a doornail. I can hear from the cartridge there. Alright, what is wrong? I'm plugged into the input. This is the output. Interesting. Well, it helps to turn the power on, and my ground popped out for one thing, but the main problem was, well, you need power. You got to turn it on. Get a little bit of buzz. I wonder if I touch this ground to the circuit ground here. Oh yeah, that knocks it right out. That's why they have that ground lead on the turntable, because that just makes it dead quiet. Perfect. Only the best. I wonder if it's copyright. Yep, John Audio Tech is going back into vinyl. K-Tel, here we come. I checked the current draw on this thing. It draws 20 milliamps, a bit too much for a 9-volt battery. Yeah, it'll run for a few hours, but if I'm going to go battery, I probably want to use like a 12-volt AA or C cells or something. Or I can use a wall wart. I think I'm going to stick with my virtual supply there. Run it that way, it'll work just fine. Well, that should do it for this. Thanks a lot to the gentleman who sent it in to me. I don't know if he wants his name mentioned, but he bought the board and sent me all the parts, so I didn't have to go to DigiKey or Mauser or anything like that. Also, thanks to Rod Elliott for the nice Phono preamp design. And I guess in another video, it won't be the next one, but sometime in the future we'll get this thing in a metal case, get it shielded and everything. Certainly won't be as bad as the breadboard here. And we'll catch you in the next one. Thanks for watching.